This is part one of what will be a two-part video for an NAD 7240 receiver that I've got in. It's totally dead. I'm not even going to plug it in because I know it's got parts that are blown, and that's the problem. I got to get parts, and I don't know how long they are away, so here's the troubleshooting. Okay, this NAD has some failed transistors in it. I know that. Let's just find out which ones are bad. One channel is bad on this one, and it is not this one. Maybe it is 0.4, and that looks a bit low. Yeah, I think it's this channel over here, just from the way that measured. Could drop across that one. I have my meter in diode test mode, and I'm just looking for any shorts. And so that transistor's looking okay. Could drop across this one. Yeah, and this one over here, shorted. Okay, so these two transistors for sure are gone. We know that the problem is on this side of the amplifier. There could be some other parts that are also popped on this. But we'll start by removing these transistors, and then we'll look for any others that may also be bad. And hopefully that's all that's wrong with this one. This one uses a 2SD 1047 and a 2SB 817, so I've marked a D and a B accordingly on the heatsink so that once I remove them, I know which way they go back in, because they're the opposite of the other channel. Just letting the iron warm up good and hot. And then we'll start by unsoldering. Actually, I'll probably use solder sucker for this one. There's a lot of solder on here to take off. I'm not a big fan of these things, but sometimes when you've got a lot of solder to remove from, say, a large transistor like this one, these can come in handy. Thing with these is you got to keep them clean, because they clog up all the time. Okay, the output transistors are now disconnected, so we'll check the driver transistors and see whether they're also bad. They're probably okay. And the other one's over here, I think. Yeah, the drivers are probably okay. I'm going to remove these outputs, so I want to apply power to the unit and see whether I've got a good waveform here on the base to drive them. It might just be the outputs that have failed on this unit. That would be nice if it is. Usually like to put the screws back in just to hold them in place so that I don't lose the mica insulator, but it might be okay. It doesn't look like it's going to go anywhere. Okay, 2 transistors out, and of course they are shorted, as I already measured them in circuit, but we will do it again out of circuit just to show you guys that they are indeed shorted emitter to collector. Hey, wait a minute. They were shorted when I measured them before. Why are they not showing shorted this time? That one is showing good this time. What the heck? And that one's showing good. Is it just the one that's shorted? Maybe it's just the one that's bad. Ah! So one went bad without the other. And it was the 2SB, which is the one closest to the front. So 2SD did not fail. That's interesting. Yeah, see? That's a normal junction. Interesting. Usually when these things pop, they pop in pairs. So we just have one that's bad in this case. So can we get away with just changing the one? Yes, we can. Although normally you change them in pairs, but again, normally they're blown. Both of them are blown. It's normally what happens. But I want to check this thing to see if there's any other faults with it before I put a new transistor in. So this is the circuit here. This is the one that was blown. So I want to check these other transistors around here to see if there's any reason why it did fail. Like the driver transistor, for example, is I don't know if it's this one or this one over here. This one might be the thermal compensation. 0.6, 0.5. I'm going to dig up a schematic for this unit. It kind of looks like the driver is down here, and it is also cooked. So that driver is blown, and that one there also might be damaged. I'm going to pull this driver out here. We'll just take a boo at this one, and check that one out as well. And then I'll dig up the schematic, which I haven't done yet. They say I hated these things. I hate them with a passion. Not the receiver, these stupid solder suckers. Okay, that transistor is also toast. That's a what is this one? It's a BD911. So the two transistors that have popped on here is Q434 and Q430. Q430, this one here, that's actually that output transistor. If we follow it through, you'll see that Q430 feeds over to the speakers, I believe. Where it goes, over here, right channel speaker, right? Goes through L402, we follow it through here. Q430, where are we? Q430, right? I'm looking at the monitor here. Right, Q430 right here is connected to here. And it follows all the way down here, up to here, up to there, and there's your speaker, right? Through L402. So this is the path here from Q430. That one's shorted. Also shorted is Q434, which is also popped, but the other side was not, which is interesting as to why this thing popped. I'm going to also check this one here, Q426, because as you can see, Q426 is the driver that drives that. So Q426, I already checked Q426 before, and it's this one up here, and it is not shorted. As you can see, 0.6 drop base to collector, 0.6 drop base to emitter, and we have no shorts. I think that's just internal resistance, but we have no short on this transistor. If I disconnect the emitter collector, it should completely read open, which, as you can see, it does. So that transistor is not bad. We have our emitter to collector and our emitter to base and collector to base junction, but emitter to collector, there's no sign of any leakage. So that driver is okay. That's weird, the way that this thing failed like that. Just one output failed, but it's also taken out this other one. And I think this has probably got to do with the bias. I think this has got the soft clipping. These units use what's called soft clipping. So it's kind of a unique design to NAD. But for sure, this 2SD 1062 and the 2SB 817, I got to change those. And fingers crossed, that might get this one back up and running. One other transistor that may be faulty is Q438, which is also connected in here. And that is this one right here. So we'll just remove this one so I can test it out of the circuit, because it was measuring some odd readings in the circuit, but it might be just due to the fact that there's other components in there. So let's just check this out of the circuit and see that it's got a 0.5 drop there and a 0.5 drop there, and we have no short. So this one is fine. Yeah. And no reverse between any of the leads. So we're good on that one. I was just kind of concerned about that one other transistor, just because of the fact that it's in the same vicinity. I would hate to change a couple transistors and miss one, only to have it go kaboom again. So we'll put that one back in, and I'm going to try and source a couple of others or substitutes for them, if I can find some. And maybe get this receiver back up and running. So when I look up the two transistors, actually when I look up what's printed here in the manual, it says this one's a Q434 is a 2SD 1062, and I think that's incorrect, because the number on the original part is it's a BD911. It's an ST BD911. When I look up this 2SD 1062, what does it show up as? I think I put it. I misread it. It's a 2SD 1062. It should cross to the same on NTE. So let me just look this one up. 2SD 1062 should be the same transistor, and it is an NTE. Now that's interesting, because it 1062 lists as an NTE 337 or 377, and the BD911 shows as a 331. So it may be just a little different power reading. But let me just look up what the 1062 2SD 1062, what it shows this as. And it is it's an NPN. Yeah, that's correct. The 377 is an NPN, and it has a rating of 80 volts collector to emitter, and an emitter to base 5 volts at 10 amps. And we'll look up the other one because I think it was higher. I think this one's a higher rating, BD911. And it came up as a 331. The data sheet, yeah, it's 100 volts. So it's collector to base and emitter and collector to emitter is 100 volts versus 80, and still 5 volts, 15 amps. So this one here is actually a higher rating. So I could use what's listed on the schematic as a replacement for it. If I can't find a 331, I could use the other one. So those are the parts that I need. The transistors for sure that I need on this. I'm going to test some of the other ones just before I commit to making my parts run. If I can actually even get in to the shop. I know Lee's doesn't carry anything like this anymore. They've got a very limited supply of parts. I'm hoping that RP, which is the other big shop, I don't even know if they're open yet with this COVID thing. I'm sure they are, but I don't know if they're open to have someone come to the shop. But they carry the NTE line, so the NTE line is pretty much a universal replacement of semiconductors. So I'm hopeful that they will have these because they're pretty standard parts, and get these replaced and then take it from there. See if there's anything else wrong with this thing. I got to get the blown parts replaced before I can power this thing up and see if there's any other faults with it. But it'd be nice to get this unit working. And the guy that owns this one's been here for a while. He dropped it off a while ago, and it's just been kind of collecting dust until I could get around to checking it. So he'll be kind of surprised when I talk to him and say, "Oh, I remember your old NAD, I got it working." But actually, he's coming over right now to pick something else up. So he'll see it all apart on the bench, I'm sure. But anyway, that's where we are now. I'm just going to check a few of the other transistors out here and see if there's anything else that's failed. I think that this is probably it, because I have checked these other ones, but I'm going to go back further into the driving circuit. But I think at this point this is all the default is. Why these failed, anybody's question, anybody's guess. One could have failed and taken the other one out. This one could have failed here. I do see some suspect solder connections here. If we look on the board closely, like in here, right? Some of these ones here look kind of flaky. So that may have been the root cause, as a voltage was lost and it caused the transistor to go into overconduction and it popped. But we'll find that out. I'll redo these anyway. And for the people that make the comments like about the Yamaha saying if it had been made in Japan, the solder connectors would not have failed. This one was made in Japan, and as I pointed out in the reply to the guy that made that smart-ass remark that because it wasn't made in Japan, the solder connections failed, I think I replied to him saying I've seen lots that were made in Japan that had exactly the same fault. Well, here's a good example here. This was made in Japan. So I'm just going to touch up some of these other ones while I have this open. one thing I'm not a big fan of is when they put this rubber compound on, because sometimes this adhesive over the years becomes it becomes electrically corrosive and can cause problems. So I'm not a big fan of any type of adhesive that's stuck to any conductors because of the problems that has been caused over the years by just adhesive deteriorating and breaking down. Another example of it is when you see it on this circuit glue that's quite often used us to have various problems. Tape stuck down like this adhesive tape. Intentions were good initially, but what happens is over a number of years the adhesive can deteriorate, and because it's organic, all adhesives are organic, they can over the time start to become electrically resistive, like this right here. This is another fine example of this. This is a I think this is just a temperature compensator, or maybe an over temperature thermistor, over temperature control. But you see, this is a prime example of circuit glue that has actually failed. When it gets crusty like this stuff is no good, and it's going to cause nothing but problems, and it has to go. So let me just get something to pick that out of there. But stuff like this causes all kinds of strange problems, because this stuff goes, as I say, it turns it into a resistor. Basically what happens when this glue gets like this. They used a lot of this stuff on VCRs to glue down, especially Sony with their beta machines, to glue down a Hall effect device to the head drum or the capstan motor, usually with the head drum. And after a while the stuff all deteriorated, and then we were getting erroneous speed reporting for the drum. So whenever you see this started out yellow, and it was actually called Sony Bond, of all things. I guess Sony made it. But anyway, when you see this stuff, it's going to have turned brown like this, and it's got to go. Whenever you see this on circuit boards, you got to get rid of it, because it's going to cause problems. If it isn't already, it's going to cause problems, and you're going to have all kinds of weird problems. I remember I think it was an NAD a while back that there was leakage between all the inputs. Like, it didn't matter what input you were on, you could hear a source playing on another input, and it was because they poured this glue down on a multi-connector, like one of these multi-connectors where it was attached to the board to hold it in place so that it didn't come, so it didn't bend and break. They poured this crap on there. I think I had a JVC too back in the last year that was shipped in, and I had to remove all the crud on it, because it was causing crosstalk between the inputs, and this stuff will. So when you see this stuff, get rid of it. It's no good having it on there. You're going to have nothing but headaches with it. So after all of this, finally settled on, I'm going to replace the outputs as a complementary pair of Sankens. So 2SA1186, 2SC2837 are the complementary transistors. Can only buy them as I can't buy it individual, I have to buy it as a set. And the 2SD1062 will be an original, which is what's listed here. I've located the parts. The parts are about a 30-minute drive from my location, but unfortunately I can't just go and pick the parts up, because the supplier works out of his house, and one of his neighbors, I guess, filed a complaint with the city, so now I have to have it shipped out. So this is going to have to sit until the parts arrive, which could be another couple weeks from now. So we'll end this, and I'll do another one when we get the parts and finish this one up. But there's your troubleshooting on the amplifier, and we'll see you in the next one. Bye for now.